All right, so back in the shop after a nice long weekend. Hope everyone enjoyed Canada Day. Yeah, I know there's some, 4th of July coming up as well. So, yeah, hopefully everyone has some nice time with friends and family. But I'm back out in the shop today, and I've reprinted my Dust Boot docking system, and I need to get that set up. But in order to do that, I need to relocate my tool changer. So I've moved it over to allow for the Dust Boot dock. I'm going to deal with that in a little bit. But for right now, what I need to do is reset up my RapidChange in its location. And I'd seen a couple of questions around how, I bought this thing, now what? So at this point, I kind of wanted to go over a video on how to get, kind of the next step. So you physically have it connected. In my case, I'm using the tool link sensor port on my super longboard and a 24 volt power connection that was available on the longboard. So I went over this previously, but basically I'm using the this one pin right here, and then over on this side going to the tool link sensor and ground on this port over here. So just stealing 24 volts on this one. Like I said, I need to clean up some wiring. I've made a few changes and just need to clean some things up. But yeah, 24 volts off of one of the switch pins, and then the tool link sensor and ground pin on the tool link sensor port. So that gives me power. A couple things to double check when you first have it set up. In my case, I have the RapidChange ATC Pro, so not the Premium. The Premium has the dust cover. The Pro has the IR sensor, so there's a brake beam sensor between this point and this point to detect collet nuts. And I also have the tool length sensor. So the setup that I'm going to show you today is mostly for, will it work with an 8 socket setup? Yes. Will it work without the tool length sensor? Yes. There's just some differences. So just keep that in mind. I'm setting it up specifically with my 6 pocket with tool setter with the IR beam brake sensor. So one of the first things you want to double check is I'm using G-Sender. I've got the machine homed. And so what I'm doing right now is I'm just breaking, I'll zoom in a little bit here, sorry. So right now I'm just putting my thumb in between the socket. And so the idea of that is to check that the brake beam sensor is getting picked up. So in this case it is. The next test you want to do is just push down on the tool length sensor. So this light changes from blue. Oops, sorry about that. Push down on the tool length sensor. The light changes from blue to red. Up on the screen, again, we should see that the probe TLS triggers. So that's how we know that we've got it wired up right, and we're kind of ready for that next step. So the next step is going to involve using the website. So if we go over to, cancel this, I was setting up something else. Dashboard. So if we go over to the website and we go to services.rapidchangeatc.com and you log in, you'll be asked to activate your RapidChange magazine. So I've already activated mine. You'll get an activation code in the box that allows you access to the portal. As well, you can pick what controller you're using. Again, in my case, I'm using the Super Longboard, not the external version, just the regular Super Longboard. If you are using the Super Longboard, there is a firmware that's here, and you do need to install this firmware. This firmware allows for the SD card to work. If you don't have this firmware or you're on a previous firmware, your SD card on the Super Longboard will not work, and the macros and pieces like that aren't going to function properly. So make sure that you do the firmware update. I'm not going to cover that in this video, but you do need to do that firmware update. So from here, I've got a couple profiles started already, but I figured I would just make a new profile and show you what that looks like. Oh, you know what? I will. It says I'm at the maximum number of profiles. Apparently, you can only have 2, so that's fine. This one was a work in progress anyway, so I'm going to delete it, and we'll make a new one. So if you had no profile, you're going to start. It's going to ask, in my case, I have one, so I could copy it, or I could just use the default. I'll use the default for now, and submit. Give it a name, and then whether you're in inches or millimeters. I'm in millimeters, so I'm going to submit that. And then it's going to refresh, and this is the page you're going to get. So initially on this page, what we need to do is determine the pocket 1 or socket 1 X, Y, and Z positions. I'm going to show you how I do that on mine, as well as how the manual shows you to do it. Just because I ended up having to print a new top cap because my spindle is quite short. So this would probably work in both cases, but my socket, I have a lot more access to the pockets and to see the nuts and collets than you would if you didn't reprint this top cap. So just keep that in mind when I'm going through it. But I will show you what both of those would look like. So what we need to do is figure out the machine X and Y and Z positions to get started. So that's the first thing we need to do. So in my case, what I'm going to do is go back over to GSender, and I'm going to home my machine. The reason I want to home my machine is just to make absolute sure that I am where I should be. Because what we're going to do is we're going to tell the machine where to go. So you right now want to make sure that your end stops are nice and tight. Nothing on the machine is changing. You're happy with your, or at least your, I've moved mine several times now, mostly happy with where your RapidChange ATC is. Because if you move anything, the magazine or the end stops, all the machine changes, all the machine positions change, and you will have to relocate the magazine. So what I've got here, I'll just pull this out, is a standard collet, nut and collet for a 1/4 inch. And this is the included locator pin that came with your set. So in your spare parts and pieces, you should have a plastic piece that says locate on it, or locator, sorry, on it. And you should have this 1/4 inch pin. So in my case, I've got it loaded up in a collet and a nut, and I'm just going to drop that into pocket 1 of my magazine. Okay, so with that done, I'm going to bring my machine forward. Move over in the X. So basically what we want to do right now is get it mostly close. Okay, so we're going to, that's maybe a little too close. So I've got it now set to precise. So I've just changed it down to precise. So I'm moving 0.5 on the X and Y and 0.1 on the Z right now. Like I said, I maybe got a little too close, so I'm just going to bring my Z axis up here a little bit. There we go. Yeah, that was silly. Okay, so go to precise. So what we're going to do in my case is I'm just going to get the spindle, go the right way here, to sit over the collet and nut. And then I'm going to bring it down slowly. What I'm looking for is just a nice, it should be centered, and sorry about that, should be centered in that pocket and over the collet. And then bring the Z down a little bit more. And I'm just looking to make sure that it kind of sits on top of the, the spindle neck sits on top of that collet nut nicely. Which in my case, I think I'm pretty much there, which is good. Okay, so what I'm going to do, point one, so let's go. That looks pretty good. And then okay, so once you're happy with that, what you're going to do is you're going to look on GSender and you want the gray numbers. So you can see X is at 184.5 and Y is at negative 184.5 and Y is at negative 775. I'm not going to worry about the 0.003 right now. So back on the RapidChange ATC page, I'm going to put in the values that I just got. So negative 180, just double check that, 184.5, and tab negative 775. Okay, so now I've got those two positions laid out. I need to figure out my Z position. I'll do that in a second. Okay, so I've saved that. Now back on the back on GSender, I'm just going to raise this up. So if you were using the regular top cap and not this low profile one, you would take the locator pin and you would put it. Sorry, I got to pull this out here. Give me 1 second. So you would take this, set it on something flat. Okay, so you would get it set up so that it looks like this. And then you're going to put this into your spindle. Sorry, you can't see that, I guess. So you're going to put that into your spindle. And you want it reasonably tight. You don't need to, crank down on it, but you do want it to be snug because we're going to use it for a couple things. So once you've got the collet nut with the locator pin, basically what you're going to do is on yours, if you've got the regular top cap, same idea, you're going to bring it down and that top cap's going to sit just nicely in the magazine pocket. Like I said, in my case, because I have such a low profile top cap and I've made room for my short spindle, I don't find that this locator is as accurate as I needed it to be. So I found that my method of seating the collet and nut onto the spindle shaft worked a little bit better. So yours, if you haven't modified it, will have a nice tall top cap with the pocket being a lot narrower. So it should work much better. So once you've located it, then you're going to bring up your locator and just wiggle it off. You can leave this on. So we need a collet nut for this next step. And basically we're going to drop it down into, not into, but just before. So what we're looking to do is on the Pro versions anyways, we're looking to just barely break the beam of that IR sensor. So now I've brought it down. So in GSender, if I click this, you can see that the IR sensor isn't triggered yet. So I'm going to keep bringing the Z down. Okay. So I've brought the Z down now, and you can see that the probe TLS is broken. So what I want to do is I want to raise it up now. It's a little bit finicky. Okay, so now we come down. So you can see that now probe TLS is triggered, so that IR sensor is broken. So if I raise it up if I raise it up 0.01 millimeter, so in this case, that's what I'm moving on my Z is 0.01 millimeter. So if I come up 0.01 millimeter, I can see that it's not broken anymore. If I come down 0.01 millimeter, now that sensor is broken. So bring it back up and then record that value. So negative 85,364. Go back over to your website and we're going to edit this position to negative 85.364. Delete out those extra zeros. Just double check. Negative 85,364. Negative 85,364. Okay, we're going to save that. Okay, so we have located our pocket, which is awesome. So with pocket 1 located, what we want to do is set our magazine layout. So we currently have it in the x-axis. So my magazine runs along the x-axis. If you had your magazine set this way, you would set that value to y. And then we have to figure out if it needs to move in a positive or negative direction. So the easiest way to do that, if you're not 100% sure, is go back over here. We'll just go to normal. So I'm in pocket 1 right now. I'm going to raise up my Z so I don't break anything. Now to get to pocket 2, what do I need to do? Well, I need to hit the X negative button, right? So to do that, I go X negative. That'll get me to pocket 2. Okay, I'm moving negative. So if I go back to the website now and I change this, direction X is correct to negative. So again, if you had a y-axis alignment, you would change this to y. But because we're across the machine, we're X, and we're moving in a negative value to get to the next pocket. Pocket offset is a standard value. You may need to tweak this in special cases, but for the most part, that is how it's set up from the factory. So factory shop, I guess is probably the better term. So I'm going to say okay. All right, so now we've set out our magazine layout and we have our pocket position. The next one is the Z move heights. For mine, and what I would recommend is leave this at 0. Basically 0 means it's going to move every time it does a bit change, it's going to move to the top of your Z axis and then come back down. So even if it's going from pocket 1 to pocket 2, it'll go pocket 1, raise all the way up, and then move over to pocket 2 and come all the way back down and then raise all the way back up. It does slow things down a little bit. And once you're more comfortable, you could come in and change this to tighten that up so it only moved as high as it needed to. But certainly for the initial setup, I recommend leaving this at 0. Okay, so the next one is my tool setter position. So in this case, I have a tool setter. So I want to tell the machine or tell the macros where that tool setter is. So for the tool setter, again, I'm going to go back over to G-Sender. I'm going to raise up my Z-axis just a little bit. And I'm going to move over. So I'm using G-Sender, just the jog wheel. And I'm moving it over. And then I'm going to come down a little bit. And I'm going to change to precise, I think. And we just kind of want to get in the middle of the tool setter button, basically, so that when the tool comes down, it's hitting the tool link sensor and can get a read. So once we're happy with that value, we're going to again go look here. So we've got negative 130 and negative 775. Okay. So over here, my X position is negative 130. I think it was 0.5, but let's just double check. Negative 30.5. And then minus 775.0, which I didn't move. Okay, so then the Z start. So basically for the Z start, what you have to be careful with here is that if you set this too low of a value, you run the risk of crashing your bit. So this is one of my longer bits. I do have a little bit longer one, but this is one I generally use as a high water mark. So if I was to load this like this, it would crash. You can see I'm hitting the side of the tool setter. So what's going to happen is it's going to go bring the bit over and run it down really fast and just crush the tool setter. So that's no good. Okay, so we can't leave our our Z axis in this position. So we need to raise our Z axis up enough that this bit will fit and not crash, and have enough wiggle room that if we were to put a longer bit in there, that you wouldn't run into problems. So you want to have this as high. You don't want to have it right at the very top, but you do want to have it reasonably high so that you can accommodate your longest bit, basically, is the rule of thumb, with a little bit of margin of error. So I'm going to raise that up maybe another 5 mils and just kind of double check this. So that's pretty good. I could even come up a few more just to give myself a little bit more wiggle room, but I think that's pretty decent. I think that's pretty safe. So again, check it with your longest bit. So I'm at negative 25.5. So what I think I'll do is over here, I'm just going to say negative 25. Okay. I'm going to say okie dokie. Now, tool measure is disabled. We want to enable that. So I click the 3 dots, I turn off disable, and I click apply. Then I can make it bigger, and then it's going to ask me what the seek distance is. So how far down should it try to seek? At current, it's set to 70 millimeters. We can do this with a ruler. Okay, so if I have, how far down is it going to seek? So basically what I want to see is roughly from the end of the nut to the top of the tool setter, do I have more, or sorry, do I have less than 70 millimeters? So that is pretty good. I'm basically 70, 65 millimeters to the top of the button. And what we want to do is we want to make sure that this value is big enough that it can seek all the way with the shortest tool. It can seek all the way to the button. But you don't want it so long that it's beyond your Z-axis travel. So just keep that in mind. So at current, 70 is pretty good. I could probably lessen that up just a little bit, but 70 is fine. And then the seek feed value is how quick it's going to do it. So how quickly it's going to do that initial plunge down to the button, and then how fast it's going to set. So when it does the second touch off, what it's going to set that to. Okay, so the last piece we need to set is a manual bit change position. Okay, so you can basically set this to whatever you want. It's somewhere on your machine. It's just a machine value that is where you will do manual bit changes. So if I switch this back, just do normal, move this back. So where would I like to do a manual bit change if I had the option? I would probably choose to do it somewhere here on my machine is probably easy enough. And you could change this in the future if you don't like it. I like if I drop the bit, it's going to hit the MDF spoil board, not into an aluminum slat. It's far enough out of the way that I should be able to work the wrenches and collect the bit without being in the way. So I'm happy with that location. So again, I'm going to go over here. I'm at negative 115.5 and negative 614.333, but that doesn't really matter that much. So let's go over here and under manual position, X. So we're going to go negative 115. And again, this is kind of rough numbers because it's just where it's going to park it, 614. Double check that. Okay, so I'm happy with those values. Great. Okay, so that's a good chunk of what you need to set up. Now, one thing I did find, and I think the RapidChange ATC team is going to change this, but there is nowhere right now to set the spindle speed. So I want to turn on two things. In my case, because I'm going to work on my dockable dust boot later, I'm going to turn macro hooks on, and I'm going to come down here and I'm going to turn tool change on, and I think everything else is fine. Yeah, turn those two things on and hit apply. And so then you'll see I get another box here for tool change. And this is where you can specify your RPMs. So the feed rate is how fast it's going to move when it's doing a tool change. So getting in position to do the tool change, moving things around, but also the RPM of the spindle. Um, so I think the max on this is about 2,400 RPMs. And then, again, that's 2,400, not 24,000. We're trying to spin pretty slow. I believe that I read that if you are over 5,000 RPM, you can do damage to your sockets. So definitely double check that you're under that. I just bought a cheap tachometer from Amazon just to verify. I think this is a $20 one or something from Amazon, just to verify that the reading I'm asking for is what I'm getting, so that I was sure that when I set the 2,000 RPM value that I was actually getting 2,000 on the spindle. It was just a good sanity check so I don't break things. These are replaceable, so should you accidentally run it too fast and strip one of these out or shatter them, you can replace them. In fact, you get a couple spares in your baggie, in your goodie bag. But I would rather not wreck them if I can avoid it. So keep that under 5,000. So what I understand is I have an 800 watt spindle and it requires a little more RPM to get the same amount of locking torque. So I'm going to go with 2,100 RPMs. If you have a 20 or 2.2 kilowatt spindle, I think you can be down in the like 1,200 range. And if you have a 1,500 watt, I think you want to be in like the 1,500 range. But there are some details there. So the other thing that I want to do on my specific setup is under tool detection, I want to turn this on. So I want to uncheck disable and I click apply. And then when I look at the tool detection, you can see that the Z target is the value that we had. So the minus 85.364, which is the value we found in the original. And then there is a Z start, which is negative 103.364. Basically, that's a calculated value that for the IR brake beam, it will use the IR brake beam to check for a collet nut. So basically, did it load the collet nut? Is the collet nut there when it shouldn't be, or is it not there when it should be? So it's just a way for error handling to happen. Again, this is on the Pro model with the IR sensor. So I definitely want to turn that on so that it can check that there is a tool loaded. So the other thing I turned on was the hooks. I'm going to do this after, but this allows me to set up a macro for before tool change and after tool change. So when I set that up, it'll be bring the spindle over, get it set up in the dock, and then come out, and then it can finish with the rest of the tool change. So I'll do that as a separate video later. This is already getting pretty long. But yeah, so now we have all of our stuff set up. You can see that these are basically all the macros. So here's all the macros. So the tool change, the TC macro, P208 is the cover open if you had a cover close. This is the important one, or one of the important ones, is P231. That's the tool measurement macro. So basically these are all going to go on the SD card. So what I'm going to do now is I'm going to turn off my super long board and I'm going to pull out my SD card. So this is something you'll need for the setup. This is a 8 gig SD card, or micro SD card, I should say. So the little itty bitty ones. So they recommend going under 32 gigs. I would say a 16 or smaller is going to give you less grief. 32 sometimes can be a bit of a problem. So yeah, if you can get a 16 gig or smaller, it's what I would recommend. The macros are super small. So, I mean, you could get away with probably a 2 gig and be fine. So I put the SD card into my computer, and I'm just going to go up on the website to export and make sure that my SD card is selected as the destination. And I'm just going to put it on the root, so select folder, and it's going to say generating macros. So file exported successfully up in the top corner is what I get. So at that point, I can go and look. So if I open up my Explorer view, I can see that I've got several macro files that were written today. So I've got the P200 macro, 203, 231, TC macro were all updated today. This was one I was playing with. This is the 201 is before tool change. So I haven't updated that in a while, so that's why it's old, since I was playing with the dust boot before. So now that we have our macros on our SD card, we're going to eject them. So that'll make it safe to remove from the computer. I'll pull it out of the PC and put it back in the Super Longboard. So with the SD card back in the Super Longboard, I'm going to turn this on. All right, so Super Longboard is on, and we're going to go back to G-Sender here. We'll be disconnected, so I'll connect back to the machine. Wait for a second. Okay, so now we're going to home the machine. So basically this next step, we're going to actually try to change the tool. Okay, so as you can see, I already have a tool in the machine. The thing to keep in mind, and it's very important, is that when you first reboot the controller for whatever reason, whether you hit the e-stop, whatever it is, it will forget that it had a bit in it, and it will forget the bit length. So you cannot assume, well, you have to not assume that it knows what the heck you have in there. So I have bit 1 in there. So there is a manual command to do this. So if I go to G-Sender and I go to console, I can tell it that there's a bit. So over on the website, it says M61 Q2 would set for tool 2, but I have tool 1. So what I want to do is M61 Q1. So I'll go back here on my console, M61 space Q1. Okay. Let me do this for now. Q1. I'm going to say enter, and it's going to say okay. So basically it's just saying, yep, I have that. So then what we want to do is call the tool length macro. So G65 P231. So G65 space P231. Okay. So what this is going to do is move the machine forward and come and do a tool length touch off on the tool setter. So this is the first time we're running this. So I recommend having your hand on the e-stop if something goes wrong. So the machine's moving forward. I've got my hand on the e-stop just in case. So it should come and just touch down. So you can see that seek rate, it switched to seek. Touched off, and it's good. So now it knows that it has tool 1 and it knows the length of that tool. So now what we can do is we can verify that our next piece works by going tool 2. Okay, so we're going to load tool 2 on an M6. So M6 is your bit change. T2 is we're calling for tool 2. Right now we have told the machine tool 1 is loaded. So what should happen is it should unload tool 1, come up, pick up tool 2, and then do a tool length touch off. So again, have your hand on the e-stop. I've got my T2 M6 command in the console. I'm going to hit run. Comes over. Spins up. Drops off that first tool. It's going to make sure that was the slow part there was where it was checking that the nut actually came off. So now it's going to come down. Again, tool 2. Nice. Now it's going to slowly come up and make sure that the tool is seated. Now if it doesn't seat the tool, it would error out and have you manually inspect. In my case, it worked. So now it's going to come over and do a tool length touch off. So now it knows the new length of the tool. So we'll do one more test and then we'll be done because this video is getting crazy long. So again, we'll go it's good to test to the end of your magazine, just in case there's any deviation or you've got anything out of whack. If you go to your end socket and try to pick up, and it doesn't, that means you maybe started in the wrong spot or whatnot. So we're gonna go T6, M6. Okay, so that's our asking for tool 6, M6. Enter. So again, we should drop off tool 2. Perfect. Comes up over to tool 6 position. Should double check that the collet nut is there. You can see this is a pretty small O-flute end mill. Comes back over to do the tool touch. So once you've done several successful ones, you can go back onto the website and you could change those feed rates to be a little faster if you wanted to, just to speed up those bit changes a bit. But anyway, okay, so that's perfect. So the last thing you kind of want to check is I'm going to do a T. So basically tool 6 is my last tool. So if I do a T101, let's say, so any tool beyond 6, so this could be a 7, sure, well, let's do 7. Let's do 7, M6. So what should happen is it'll drop off tool 6 and then go to our park position. So we'll hit enter. So it's going to come over. Drops it off, makes sure that the nut disengages. Perfect. And now it's going to move to our park position where we can do a manual bit change. So at this point, it pauses the machine, it sets it to hold. So to resume, once I put the new bit in, so in my case here, you know what I'm going to do? I will swap here. So now we get our wrench. Oh no. Sorry. Want this tool in the caddy, in the magazine, and I'm just going to put the pin in that we were testing with earlier. See the pin, tighten it a bit. There we go. Okay, so now it's held. So once we had the tool in, we hit the little unlock button here to resume, and it'll come forward. There's our tool touch. Back up, and it's ready to machine. So that is our finished install of our RapidChange ATC. So there's lots of things, like I said, on the website you can play with and adjust. If you go back to here, kind of the steps, determine your pocket position, including your Z. Make sure you set your magazine layout properly and tell it which direction to move properly. Make sure you set your tool setter position if you have one, and double check excuse me, double check your tool measurement settings and set a manual park position. Then if you have the IR sensor, you want to make sure you have tool detection turned on, and you can adjust these values if you need to. If for some reason let's say your collet nuts were a bit special and they were really long, you could adjust that value to account for like a really long collet nut or something like that. Once you have everything saved and ready, you do your export of your macros, restart your controller so that it loads the new file, and away you go. So you can come back now that this profile is here. You can always come back to it and make changes. I'm going to come back later and do the hooks for before and after tool change so that it can move and position and pick up and drop off the dust boot. But like I said, I'll do that a little bit later. Awesome. I hope this video was helpful to some. I know it's pretty long, so I don't expect it's going to get a ton of traction. But hopefully, like I said, it was helpful to some. and a reference point for others later on in the journey. Awesome. Thanks for watching, guys, and see you in the next one.